The basic of PN junction diode. Solid state technology. What is it? Let's go forward. The science involving the movement of electrons through a solid piece of semiconductor material, typically silicon or germanium. That thing means the solid state technology. Okay, let's go to the next thing. Pinch of voltage. The operating condition of a field effect transistor where increasing the V underscore ds causes no further increase in I underscore d. It is similar to saturation in a BGT. So if you did study about the saturation, what is saturation in the BGT, then it shouldn't be anything to you, like what would be on, what would be off, those kind of things in the saturation. Next, repetitive peak reverse voltage. The maximum voltage an SCR can sustain. You have to remember the maximum voltage which SCR can sustain, and why we have to sustain it? We have to sustain it in the reverse bias condition. If all those conditions met, then it is repetitive peak reverse voltage. The next one, depletion mode. You might already know about depletion mode. There are positive charge, negative charge, depletion region, etc. You might have studied. Let's see. A method of operating for a JFET or DMOSFET in which the transistor is totally on maximum ID when the VGS is 0 volt, and by making VGS more negative, the flow of the electron is reduced or depleted. So what did we do here is we used an operation method for JFET and DMOSFET, and in this operation method the transistor is totally on, here is maximum ID, when the VGS is 0. Alright, so you have to remember those conditions. Transistor is on maximum ID and VGS is 0, and this is a method of operation, and this is applicable for JFET and DMOSFET. Do you know what is MOSFET? MOSFET is metal oxide sulfate, and FET means field emitted transistor, maybe. I'm not sure, you have to look at Google for this. Okay, and by making VGS more negative, the flow of the electron is reduced or depleted. So it makes the VGS even more negative, and negative electron to negative electron, it actually gets separated, and when it gets separated it will go to the opposite side and it will get depleted. That's the basic concept here. So depletion region, we already know what was a depletion mode. Depletion region would be even easier for us. The area, see, we saw here the region, so the area would come, this is the basic sense we thought, the area that lacks electrons between the p-type material and n-type material of the semiconductor device. So imagine this is area, and middle area there is a lack material of p-type and n-type, and that thing is the depletion region. Alright, let me read again. The area that lacks electrons between the p-type material and n-type material of the semiconductor device. See, for example, here is p-type, this side is n-type, and this middle there is a lack of p-type and n-type because those are those two sides, and this middle of the semiconductor device is the depletion region. Bias. This is very confusing yet the easiest thing ever. Let's see. A DC voltage applied to a semiconductor device to turn it on or off. Okay, this is the simplest explanation I have ever read. And so all you have to remember, you have to apply the DC voltage on the semiconductor to turn it on or off. Alright, don't don't say AC voltage, this is DC voltage. All right. Compensation diode, sorry, compensating diode. All right, my apology for saying that before. Compensating diodes, diodes used in a class AB amplifier that each provides a voltage drop across the base to emitter junction. So what did we understand from there? Diode used in a class AB amplifier. You have to understand this is a class AB amplifier and diode used on that. Each provide a voltage drop across the base to emitter junction. So each of that process provides a voltage drop across the base to emitter junction. For example, base, for example, emitter, base to emitter junction of a transistor to keep it barely on. So that voltage drop base to emitter junction will, even after that, the transistor must have to be on. In fact, it have to be barely on at least, if not properly, and thus eliminate crossover distortion. So as it is barely on, we can sense that there are lackings of other stuffs here, so it will eliminate the crossover distortion. Good. Now let's go to the enhancement mode. Let's see what it is. A method of operation for a DMOSFET or eMOSFET. We already know what MOSFET is. Okay, so where a transistor has a positive VGS. Before we learned about VGS equal to 0, but this time the VGS would be the positive thing. That forms a bridge between the drain and source. You know, there would be a source where the things will enter, in the easiest way I'm explaining, and there would be a drain where the things will go out, or depleted or something like this. So there is a drain and source causing current flow through the transistor. Alright, so what we have understand, in this method of operation there would be DMOSFET, eMOSFET, where the transistor have to be positive VGS, of course, and that thing will form a bridge between drain and source and cause the current flow to the transistor. That's kind of cool actually, if you can remember it. This is enhancement mode. Alright, in enhancement mode, bridge will be created, blah blah blah. Okay, next. Tunnel diode. This might be our last topic. Let's see what is tunnel diode. A semiconductor device that provides high speed switching, making it useful in communication system, particularly high frequency applications such as local oscillator for UHF TV tuners. It is also known as Esaki diode. Okay, this is a new thing. Esaki diode. Esaki diode and tunnel diode are same thing, and this is used for communication and let me see, switching, making useful communication, yeah, those kind of stuff. So all you have to remember, this is a semiconductor device which provides high speed switching. Alright, and making it useful for communication, because if when you have high speed switching, it will be definitely useful for communication, particularly high frequency application, etc, etc. Just remember, this is a semiconductor device and it provides high speed switching. Also it is known as Esaki diode, and if you want to explain more, then it is used for high frequency application, communication, blah blah blah. Alright, so that's it for today, and hopefully it would be very useful for you to clear your concept about basic PN junction diode, right? The basic of PN junction diode. And if you have learned the basic today, then you can at least have little bit idea, and later we will able to do a lot better, a lot more interesting stuffs. Thank you so much. Have Let's learn